Hello, this is James Stone, and this is a video to accompany Introduction to Scripting for the School of Visual Art for Penn State. And in this video, I'm going to talk a little bit about what we've learned in the class so far, object-oriented programming, and how I might approach a simple idea of creating a game. So what I'm going to do is basically create a two-player Pong game, right, with paddles on each side, and each player is going to be controlling by a different mechanism. One will be controlled with the mouse, one will be controlled with the keyboard. I'm going to show you start to finish how I would approach the problem, how I might think about objects and build things in kind of an iterative, kind of modular process. So it won't be perfect, probably will make some mistakes along the way, but I want you to see like how I'm programming, how this actually goes together real time, so that you can kind of see how someone who has some experience approaches it. So the first thing I usually do is just kind of build out the scaffold, right? We have the void setup, void draw, and then we need to define a size. And you'll notice I just run things a lot to make sure it's running. I'm going to do a white background just so things are clear. Okay, awesome. So I might be thinking about having like a puck that might be an ellipse. I might even just start experimenting with what that might look like here in the draw statement. Okay, and I might change the color. There we go. And then probably we're going to need something like a paddle, but I'm going to come back to that. The first thing I want to do is kind of get this puck moving around and kind of interacting within the space. So I'm going to think about how I can create an object to become this. You'll note I use a capital letter here. It's just a convention of Java. And I'm going to use an object within this. So this might be a little bit advanced, but you could always use a float or an int for your x and y value, but I'm going to use a vector called the p-vector object. So if you want more information on that, you can check this out in the p-vector. And I think I added a video that you can learn a little bit more from Dan Schiffman as well. So p-vector. Okay, and so I'm going to need to create a constructor. So what I like to do is to create a base constructor. So maybe I'll make that red by default. So the easiest way for me to initialize this is going to be to pass floats in. Okay, and this is just a lot of boilerplate, and then I'm also going to create a method called display. So the fill, I'm going to use the color value. No stroke, I'll leave the same. This is going to be location X, location Y, and then I have the size of the puck. I think that I might want to change the puck size. Maybe I'm going to have multiple pucks in the future, so I'm going to add a new value for that. Okay, so this is a lot of boilerplate, right? Just to create our first object, but it gets a little bit faster as we create more and more. I have everything looking the way I want here. I've got class puck. So the final thing that I need to do, and I'm going to leave this on the top in preparation to move it to a new file, is to create a global variable. So puck. And then I need to instantiate that variable, puck. And then I'm going to give it this the width divided by 2, height divided by 2, and let's give it initial velocity of 0, and then a color of, let's give it a different color. And here in the draw, we want to tell the puck to display. Just a little syntax error there. Color NNC on class. Just correcting a couple of small mistakes here. Expecting R parens, so I'm missing one more here. Okay, new p vector. Also misspelled here. So yeah, you can see this is a pretty common thing. The spelling and things like that. So size equals 50. Can't be resolved to a variable, float size. So I accidentally have put it in the wrong place. And in fact, this should be in this constructor, and I'm noticing I need to call this. So when I run this, it basically is going to call this constructor first. And size, float, size. There we go. So we've got the green puck, and I can now change this color to something else very easily, as well as change the location, right? Divide by 4. So pretty versatile object. It can kind of display itself, and now what I want to do is get this moving around, and I'm going to use the velocity p vector to do that. So we've got display, and I'm going to add another method called calc. But the first thing I want to do is to give one of these a value, and we will start by moving along just the y-axis of a value of 1. And this is a pretty common structure you'll see a lot with Dan Schiffman's code as well as my own, having objects with a calc and display. And so what you do is you run through each object, each frame to calc. And what we're going to do is figure out how this position might change, what things might change during that frame, and then the display actually draws it to the screen. So we've got void calc, and what I'm going to do here is I'm going to, and this is a little bit easier because I'm using the p vector objects. I'm going to take the location and I'm going to add the velocity. Right, and if we were using regular variables, you could do something like this, x plus equals, which is just shorthand for x equals x plus. Velocity x, right? And you could do this for both the x and the y axes. But this is being taken care of for us by this object, the p vector object, with the method of add. So that's what's going on there. We're just adding that vector to the other one. And let's take a look and see if it works. And you'll notice I just kind of add one simple thing at a time, ideally, and run things to see if we're getting the expected behavior. So the next thing that I need to do in my draw loop is to run the calculation every frame. We should see the behavior of it moving off the screen, which we are. It's not exactly perfect, but we also want to take this background and clear every frame at the beginning of our draw statements so that we can kind of see the movement. And this gives us quite a bit of interactivity because we could go now and we could increase the velocity when we're constructing. And I'm going to go ahead and take this already and create a new tab called puck. Okay. Paste the contents in, save it, and that should clean things up for us. The goal is to keep this really clean, kind of your base PDE file, so it's really easy to read, easy to kind of scan and see what's going on. So here, if we change this from 1 to 10, we should see it faster. And if we go and change this to a vector as well, say -5, should see some sort of diagonal movement. And so everything's working the way we would expect it to. So I'm going to go in for my game. I'm going to create, so when the puck hits the bottom and the top of the screen, it's going to bounce, right? So the way that I could do that is by taking this calc function, and then I can add additional conditional logic. And what I can say is, if location y is less than 0, or, right, so this is like, or location y is greater than the height, which is the height of the sketch, then we're going to do something. And let's see if we have a helper function that's going to help here. So I'm going to use multiply, and I'm going to multiply it by a float. Actually, I'm not, because that doesn't make sense. So what I want to do is I want to take the location, the y-axis, and I want to invert it. And so I can do that by taking this and multiplying it by -1, right? So if it's just kind of flipping the sign back and forth on the y-axis, and it's flipping the sign on the location. But it's not the location that I need to flip, it's the velocity. So there we go. So now it's bouncing. And if we were going to contain it within the entire screen, we could add additional conditional logic, right? For the x-axis, should be the width. We should get the behavior of this bouncing around inside the screen, right? Which is not exactly what I want, but this is very similar to the Pong game. So great. So I think probably this is enough for a prototype, right? We've got the semblance of a puck. We've got the velocity. Everything's moving around. We can change that. So if we go back to our constructor and we change this to, say, 1 and 2, just get this nice slow behavior, the bouncing off the edge. And we'll remove that additional conditional logic that I created. And we could even leave a comment if we're beginning and say constrain to the and the thing is, let's see if it touches the edge. You'll notice it kind of bounces over. So that's a little bit nitpicky. I might come back to that later. But that's something to leave to do. I might leave a to do actually above this. Okay, awesome. So this might seem really simple and a lot of work just to get this puck going, but what we can do is use a similar process to create our puck. Or not our puck, but the paddle, which will be the next step. So to do that, I'm actually going to just grab this class. And we could use inheritance and that type of thing, but I'm trying to keep things simple. And we're going to call it a paddle. And let's think about how this is going to change. First, I'm going to change the name of the constructors. First of all, on the paddle, I think I won't need the velocity, but just the location, because I'm going to set it pretty explicitly. I think I am going to set the color, and the size is going to be different. I'm going to use a float. H for height and W for width. And let's see here, we can get rid of the velocity and the velocity here. And we have the color still. I'll need to think about What needs to change here, the height. And I'm going to have to rename these. We'll call it the init H. Then we have the color. We don't have the size. But we need to define all of these values to begin with. So we're going to do H, and we'll just call this, the height will be 100, and the width will be, say, 20. And I like to always keep the width above the height, just because it's a little more consistent. You'll see here, we'll do the same thing. Okay, and for calc, I'm going to clear this and just leave it blank for now. In fact, I might get rid of it completely. I'm not even sure that we'll go use that. And then for the display, I'm going to use a rect. And instead of size, we're going to use width and then height. Okay, great. So this is just kind of a simple object that uses a p-vector for the location, which we can set. We can set the initial location, the height and width, and the color. So we'll do that, and we have a way to display it. So now let's go and use that. So we're going to create a new variable. So paddle, and then we're going to instantiate it. So I'm going to instantiate it, and the X value will just set to, say, 20. I'm just kind of making a wild guess here. Here we'll do the height divided by 2 so it's centered. And then we need the height and width of it. Let's do 100, and let's say 20, the width and height. And then we need a color. Let's just make it white for now. And then finally, and I'm going to add some spacing here just so we have some clarity, we need to be able to display it. So there we go. Problem was I have a white background, so we'll use 0 black instead. Here we go. And I have something reversed here in the way that I'm thinking about things. There we go. So I have these a little bit backwards how I'm thinking about them. So I'm going to put them back the way I had them before. I actually do the height and then the width. So I try to follow the convention of processing. Okay. There we go. So before I start creating the interaction of these two objects and how that's going to work, I'm more interested in making it tie into the user interaction. So you'll see we have calc, display. You're going to run through the draw loop. And I think the way to think about it is like these are kind of defaults, things that you're going to do every single screen, and then you're going to go through and actually display these at the end. Calculate, and then here we're going to say interaction, and under interaction, and I normally wouldn't put these comments, but I'm just kind of showing you how I might organize the code. All right, so what we want to do is to set the paddle location rotation Y to mouse Y. So that's pretty much all we need to do. It's not perfect, and I might leave a note to myself what kinds of things are not quite right. So at the top, it's hard to get to the top, and then at the bottom, it's hard to get to the bottom. And I think it's because of the rect mode where we're drawing. Maybe let's try and address that problem right away. So go here. So now it's with the center, so it's a lot better. And we might put it to do but basically we've got that same kind of interaction, right? So there's another thing that might be useful for you as you're kind of experimenting even at this early stage. And you can go sketch, tweak, and this is called tweak mode, and I want to show you how this works. So you saw I was changing the value, but if you run with tweak mode, you'll see you'll get access to different values that you can change, that can change the sketch. Now, unfortunately, we don't have these with the constructor, but if we were to change them in a different way, we might have access. But you can go in and start like changing the color values of like the background, and you can do this live while the sketch is running. So this might be an interesting thing for you to experiment with values and kind of see other ways to manipulate your objects. Okay, so we've got one paddle. Really, we need two. So I'm going to go ahead and already start that, and we'll just start giving these bigger names. So we'll call it paddle player 1. Player 2, for lack of a better way to do it. And this we're going to set to width minus 50. And you'll notice I'm kind of running it, checking the error, correcting the error, and kind of going through that whole process. Cool. And we can even start to experiment too of like how this might work by reversing our vector, right? So if we do -1 vector, you could see how we might try and stop that. Of course, it's not working yet, but we can already kind of see how that's working. Now, player 2 should be at width minus 50, and the color should be 0. Perhaps we're off the sketch. Nope. We instantiated it, so what's missing here? We're not displaying it. Okay, so we've got one here, and now this one we're gonna run with the keyboard, right? Now, the way you handle interaction with the keys is a little bit different. And I'm going to look this up really quick because I don't use it all the time. Here we go. This is exactly pretty much what we need. Literally just going to copy and paste this. All right. So if key equals coded and then nested within that, if the key code equals up, then they're changing the fill value to this. But what we're going to want to do is take the player 2 location y and plus minus or plus equals, and then I think what I'm going to want to do here is create a value for both. So the way I'll just do that initially is to create another global, and we'll call this and let's start with a value of 10 for 10 pixels. If you get an error like that, usually the error is here. So we've got too much stuff hanging out. You'll see I'm clicking on this to see where it's ending. Else if, and that's this one. Hitting tab and shift tab to clean that up. There we go. We've got the mouse, and then if I'm pressing the keyboard up and down, actually getting the opposite effect that I wanted. So I'll just flip these two signs because we want to, if we're pressing up, decrease the value, right? Because it starts at 0. And then here we'll do plus. So now with the down arrow and then the up arrow. And the problem is it's pretty slow. And it's the reason why I changed this before. Displacement. There we go. Maybe even a little bit higher. So the person with the mouse is going to have more control. I might think about how to make that more fair in the future. So now I've got the two pucks, and obviously it's just me here by myself playing, but I can move these up and down. So kind of the final piece of this is to figure out how to check for a collision or touching this, and then also for it to reverse the vector, kind of what we did before. So let's think about what's the best way to do that. Let's start with simple collision checking. We'll use the center of this object, and we'll use a way to create that with the vector by checking the distance. And we'll start there, and then we'll see if there's a way that we can kind of refine that process. Okay, so and the reason, just to explain, the reason why I'm using Keypress here, this is something that's going to be automatically executed. So every time I press a key, like 1, 2, 3, this is going to be executed 1, 2, 3 times. If I just check for a key being down, the problem is you're going to have to deal with this thing called debouncing, because you're going to run through the key being down. Like let's say I held down the key for 1 second. it will actually run through 60 times, right? Rather than just an individual key press. So it's not the kind of behavior that you want. So every time you're dealing with key pressed or mouse clicking or that type of thing, you're going to want to use these helper procedures or functions from processing. And that's the reason why I'm doing that. All right. So here, let's start with checking just one to begin with, and then we'll figure out how to do the second one. So paddle player 1. I think the place we want to put this is on the paddle object and create a way to find out whether or not an object is touching it. So I'm going to go to the paddle object and I'm going to create a new method, and it's going to return a Boolean, true or false. And we are going to call this is touching, and we're going to pass into it a p vector, and we'll call this test object. And then we are also going to need a radius, because this is just going to be a simple collision testing of that circular object. So we'll call this float radius. And what I want to do initially is just set this to false, right? So return false. And so this is always going to return false for the moment, right? And what I want to do is think about, okay, in the calculation, the interaction, we're going to put this above the calculating because we want to see for the previous frame if it hit, so that if it touches, it's going to move back. And we're going to say paddle player 1. So if paddle player 1, and then we're going to call that is touching, and then we're going to pass into it puck location, and then puck size. And I might even just go right now and think this doesn't really make much sense, the name of it. And I'm going to rename it R, go back into puck and refactor that. So size is going to be R for radius. And these are just short. It's probably not the best way to name them, but I just want to do it very quickly. And then we're using size here, radius, and radius, right? So if this is going on, then we're going to take the same kind of thing and flip the puck x-axis, right? We'll say if it's touching, then puck location x times equals -1, right? So we're flipping the sign. And of course this isn't working because we don't have that. And what I want to see is now we're going to go back to paddle and we'll say return true. And what's going on is it's just flipping the sign constantly so we don't get any movement, right? So we can be assured that that's working. So now we need to kind of actually make that test. So we'll just start with the center of the object and we'll say something simple like location, which is this object, which is the paddle. We'll say if location, and you'll see if I hit dot, I've got all these different things we can do. And I know there's one called distance, which shows the distance between two p vectors. And then we'll give the second one, because we're looking at the distance between that. And then we're going to pass in the test object. And that's going to give us a value, right? So if it's 50 pixels away, if it's 100 pixels away, the two vectors, it's going to give us a value of that. So we're going to construct our conditional statement, right? And in fact, I'm going to simplify things, but for now, I'll write this out longhand. We'll say var float distance equals this. And then we're going to say create a variable test result. And then we're going to pass that at the end. And here we're going to say test. We'll say if test, no, sorry, not test result, if distance minus the radius is less than 0. So basically, the distance, if you remove the distance from the distance of the object to it, if it's less than 0, that means in theory it's touching, right? Is this the way I'm thinking about it right now? Then we'll set test result equals true. All right, so we had some sort of interaction, but not quite what I was expecting. Okay. So the problem here is I'm changing the location. Going off screen. What I really wanted was the velocity x. And so now it should go the other direction. There we go. And you'll see it wasn't quite right. And there's a couple of reasons why that might be. But the first thing is, if we look at what's going on, so it seems like about double the radius. And I think what's going on there is the radius for our display is actually a diameter, right? It's the diameter that's being used in this ellipse function. So if we go and take the radius times 2, we should get consistent results now. Perhaps it's closer. And then, in fact, I think that's actually correct. So if we're thinking about the center of this object, that's where it's hitting. So the next thing we need to do is change the value slightly. So the radius from the test object. So we could create a new p vector for this. So instead of using the location, we could add a value to it. And the value would be half of the width, so that we could test the front edge of it. At least in this case where it's facing to the right. So I'm not sure if that's exactly the direction I want to go. We'll just leave it for now because you'll see we actually have the interaction that we were looking for. It kind of works already. Cool. And since we did this for player 1, we can also do it for player 2, right? Same thing. Nothing really should change. Buck location R. So let's see. Got this one. And there we go. So there's a little bit of cleanup still, right, on the top and bottom, and it's not quite right here, but we've got kind of the basic interaction. But there's one more step, right? We have to obviously keep track of score or something like that. And the biggest thing is to determine when it goes off the screen and then reset the game, right? So let's start by breaking those down. I think the first thing that we want to do is to see if the game ended and restart it. And we're going to do that in this kind of calculate section. And I'll start just by writing things here. We might move this into a function or into an object itself later, right? So what I'm interested in is if the puck location y is less than 0, or sorry, we don't want to do y, but the x-axis, right? It's less than 0, or right, and this is like or puck location x is greater than the width of the screen, then we're going to do something, right? And let's think about what we're going to do. To do that, we'll just say if that's the case, then puck location x equals the width divided by 2. So basically kind of resetting the scenario, right? Very simple way. Okay, and here I'm going to let it go off the screen. We'll see what happens. And then it starts again, right? And I think what we really want to do here is to reset to the center of the screen and puck velocity. And we might just create a helper method for this in the puck. So kind of what I'm thinking is the puck should go at a random velocity, right? That's kind of like how the game works. Up to a certain value is the top value. And so we'll call this void reset. And here we're going to set the location x equals the width divided by 2. Y is the height divided by 2. And then we're going to set the velocity x equals random, and we'll say from 1 to, let's say 5 is our highest value. And I'm just hard coding these right now. They could be set in a way that could be, a constant, this style constant, where we could define up here or in the class itself. But for now, this is, I think, fine. Void reset. And one thing we might do is here say puck reset, so we get some sort of random value to begin with. And let's try and do that here as well. So we'll do puck reset. You'll notice what's nice about that is before we're just setting the location and doing all this stuff, and you have to kind of read each line to understand it. But now when it says puck reset, it becomes a lot more clear, and this could even be on one line because it's very simple statement. It reads a lot more like English, right? If puck location x is less than 0 or puck location x is greater than the width, then puck reset. So as you see how this is sounding a lot more like English, that's kind of the goal that you want. You want these to be readable. And this is a lot easier to keep in your head as you're reading through the code to understand what it is, right? There we go. And so we've got the game resetting, right? So the next part of this, I think, to kind of make this like a final actual game, because you're playing, right, against someone, is going to be some sort of score, right? So we'll just create this in a very simple way for now. And you'll see I'm going through and reorganizing as I go. Okay, we're going to use a int. Okay, and we'll do this in the setup with puck reset, and we'll set score equals 0. Okay, cool. So we've got a variable, we've got a value, and now we have to display it somehow. So let's go back and let's search for text. We'll see how that's being used, right? Text size, fill. So basically, it's the text that I'm going to use and then a placement of it. All right. So I'm thinking maybe I might be more complex with that later, and it's going to get a little bit cluttered having all of this stuff here. So I'm going to make the decision right now that instead of having this int player score, I'm actually going to create a score object. Okay, I'm going to grab my puck, paste it in the score. I'm going to call it score, and score. And I'm going to get rid of all this extra stuff like calculate, and I just want the display. And I want to think about what kinds of variables do I need. I need a location of the score. I don't need that. Do I need a color? I'm going to have one just in case I want to change that later. We're going to need an int, and we're just going to call it value, for lack of a better number, or a better way to think about it. Color, int, value. And then we have also text size. So let's think about what that might be. Int score text size. I think that's going to be easier to handle as a constant, so we'll leave that off. So value, location, velocity, color. We have a value, and I think that's all we need. So we'll say value is 50. Color is going to be black, so we can see it. Or maybe we'll make it blue, just to kind of give a differentiation. So we've got a location, a color, a value. Location, color, value. And here would be the easy way that we're going to initialize it. And the value, we're not really going to want to change that. We're going to kind of always want this to be 0 to begin with, right? And the color, maybe I don't care to change the color initially. So the biggest thing is I want to be able to define a position, right? So get rid of this. And then for the display, we want to use text, right? And it should be the value and then location X, location Y. So that should draw out our text. We don't need any of these. And this might seem like maybe a lot of overhead, but the thing is, like, I want to think about the score as an object. Maybe it's too granular, but I know I'm going to repeat it, so I don't want to have to write several times a score and then draw it and have all this extra stuff. And then I think I'm probably going to want to really change the visual aspect of how the score is. Maybe I'm going to do like a dial or like a gauge or some sort of indicator rather than text in the future. So this allows me that flexibility, right? Okay. So now I've got my score object. Let's go ahead and create some instances of this. Score player 1, score player 2, score, or sorry, let's do score player 1, score player 2, just to be consistent with what I already have. And we're going to say player score player 1 equals new score, and then we have to give an X and Y position, and let's just put it, we don't want it to overlap the paddle, so let's try and put it let's try 10 and then height. Let's just do 10 and then 10 and see what that looks like. And the final part of this, and I'm just going to start with the player 1 first, so I can see if it's looking the way I want it to look. And here we've got the puck display, the player display, and now we're going to go to the score display, right? And we've got that 0, and it's tiny, right? So let's go in here and we'll set the text size to something huge, like 64, right? All right, so we've got a big 0, and we're going to add a larger size to where we're instantiating it, maybe 100. And I'm thinking, let's keep these towards the center. So width divided by 2 minus 100. So too far down. Okay. Let's get the player 2 going. We're going to change this to plus. Okay. So now we've got those scores working, and we could test this just for fun by just taking the score. So we'll just add 1 every frame. We should see it incrementing very quickly. Great. So that's exactly what we want to see, right? Cool. Let's see what other kind of stuff we have here in text. Text align is the other thing we're going to want to use. Text align right center. We're going to want to grab this one, have the text align to the center, and we'll do center top. This is going to probably actually be what we want to do. Text align center top. We'll go back into our score display, add this as one of our defaults at the top, and make some adjustments as well. Now, when we instantiate it, this value probably should be 0 because we're going to align to the top now. Perfect. And then we might even go and set the color of the text. Let's see how that's defined. It's defined with the stroke. So we'll do black and do a translucent color, like 64. working. Looks like we use the fill function. There we go. So now we got our text color. Let's try my original value. There we go. So we've got a nice translucent score. The nice thing about that is it should show our ball going underneath it, which is kind of a nice effect. Okay, cool. So we've got that, and we're kind of automatically incrementing here. The next thing we want to do is add another conditional. And the conditional we want to use is this one that we've already defined. So basically, this means it's out of bounds and we're resetting the game. So we're going to expand upon what that's doing. So I'm going to add the curly braces back. Puck reset, we're going to leave that at the end because we know we want to do that. And what we want to do here is say if puck location x is less than 0, then we are going to, so if it's less than 0, it's on the left side. So player 1 loses the point, not really loses the point, but player 2 gets the point, right? So I'm saying this out loud because it's the way I want to think about it. So we're going to say then score player 2 plus value, and we could just do plus plus, right? We've seen this before. This means the same as plus or equals score value, whatever, plus 1. It's just shorthand, so we'll do increment by 1. And then we'll do the same thing, except for greater than the width. And we'll say player 1. And then we always want to reset in any situation. So basically we're checking to see if it's either this or that, and if it is, then we're checking if it's this, we're incrementing this player's value. If not, if it's the greater than the width, then we're incrementing this, and then we're resetting the puck, right? And perhaps it could be written in a different way, but this is kind of like a winning state, right? So just leave that as a comment. And then we say like player 2 wins. And, like when you have multiple things like this, if it's obvious, right, here's player 1 or player 2, I would just leave them the same. And it just depends on how you think about this. Like you might find that it makes more sense to have them in the order that they're players, right? Player 1, then player 2. That's totally fine as well. Just whatever's the most readable and you think is going to make the most sense either to yourself or someone else later on. Great. And I might even take these right now and kind of clean these up onto single lines just so it's a little bit cleaner. So let's see what happens. 1, 2, 3, 4. Now, I'm looking at this and I'm going to clean up a couple of little things just so we can have something working much closer to what the actual game would be. But one thing I've noticed is the velocity is always going to the right. So I've made a mistake, right? So if we go into the puck, and this is kind of the beauty of having created that reset method, this should be -5. And so now we should see a consistent switch for each one. All right. So that's pretty much it. A very simple Pong game. There's some refinement that needs to happen, maybe better collision detection on the edge of this, which could be done in a number of different ways. You could, in a very simple way, create an array of vectors that you're checking the distance from. There's more advanced ways to actually check the collision as well. But I just wanted to show you this is the way like I might approach a problem. This is just all out of my head. So we're looking at like, what was my thought process? How am I breaking this up into different objects? And like, what am I left with? And so I've got 3 objects: paddle, the puck, and the score. They're all in separate files, right? And it makes it a lot cleaner to deal with. And they're actually all very similar, right? I don't know that I would necessarily advise going with inheritance this early on. You might do that later when you see, oh, there's a commonality between all these objects. Let's create kind of a super class to contain all of that. And if we go back here, you'll see right now we've got just a couple of globals, so we don't have a ton. In fact, most of these, in fact, all of them are dealing with objects that we're creating. In our setup, we're setting the size, which all of these have to do. And if you're creating a game, you might think about using, in this new processing, full screen method instead. This is going to run full screen, which is pretty awesome, right? And if you're using calculations like I did with the width and height and that type of thing, it's going to still run just fine. And then basically we're creating our objects, instantiating them, right? Creating a new puck. We're calling the reset here. Now, one thing we could do, we're passing in the velocity here. We could say, well, that doesn't really make sense. I'm not going to really create a puck with velocity. We did that initially to test it, but we're not really doing that anymore. So one thing we could do is create another helper constructor, right? So we could take this helper constructor, right, which is calling the initial constructor on the top. And we could get rid of the velocity, and we'll leave the color. For example, maybe we don't even need the color, right? We just want to tell it where to start. Maybe we don't even want to tell it where to start. We can actually kind of roll a lot of this stuff into it. So we could say puck location is the width divided by 2, and the height divided by 2. And that would be just kind of the default, and the color we've already got set, and the radius. And we could go and set the velocity. We'll just create the new object, and the best way I think to do this is to call this this reset. And since I'm probably not going to use it too much anymore, I actually just get rid of this constructor completely, including this one. So we kind of already know what this values are going to be. There's no real need to have all of this complicating things. So we can just say there's a new puck. You can get rid of the reset because we've already rolled it in. Run that. There we go. Right? And if we don't like the color, we'll just go in here and change this value. Let's say we're going for kind of a grayscale style theme. Oh, sorry, I'm in the paddle. Go back to the puck. There we go. Got our dark gray translucent. And we could change the size of this now to something smaller, for example. Could make it huge. We really have a lot of flexibility here. And we could really change the state of the game too. Like say this is starting at 50 and we could make it more difficult, right? By, for example, if we have a winning state, we have the puck reset. We could, before we reset it, we could say puck R minus minus, right? And so every time that it wins, and I'm just going to change it so that it's more obvious. We'll say minus equals 10, so it's really obvious. What's going to happen is every time someone makes a score, the puck is getting smaller, right? So yeah, so you have a lot of flexibility here. I'm just going to comment this out because maybe I'm not going to experiment with that. But I'll go ahead and post this code online so you can take a look. And if you have any questions, you can email me. And you'll see how simple that is. Now we're just creating our objects. Our puck is very simple. And we might think about these if they need to be changed and how the constructors might look. And I'll remove these comments or clean up a little bit, interaction. And you'll see still have a to-do goes off the sketch. And then we have the interaction and the procedure below. That's just kind of a note. And then we're calculating, right? We're basically saying if player 1, paddle, is touching the puck location with the puck radius, then take the puck velocity x times equals -1, right? And so this is just flipping the sign, right? And if you remember back to math, if you have a positive and a negative, it becomes a negative. And if you have a negative and a negative, it becomes a positive. That's basically what's going on here. If you can remember back to early math stuff. Here we go. We're calculating the winning state, seeing if there's a winner, incrementing the score based on the location of the puck, and then we're resetting the puck, so resetting the game state. And then we're going through and calculating the puck because it's the only object that's moving based on some sort of vector or something that's calculated every frame. The paddles are just being moved through the interaction, so we don't need to calculate. And then we're displaying out all 5 of our objects. And down here, this is the interaction for the keyboard, which I mentioned. The reason for this is so that you don't have to debounce. So every time you press the key, you get consistent movement or consistent interaction. So that's it. Thank you.